Okay, we're going to look at using logs today to solve exponential equations. And so what's happening here is I have 3 to the power of something that is supposed to equal 30, but I've really got no clue what I could multiply or what I could raise 3 to the power of to get to exactly 30. So when that happens, I'm just going to use the log function. And so all that I do for that is we're just going to add a log to both the front and back. So log of 3 to the x power equals log of 30. And so I will separate this a little bit by bringing the x up front. So x log 3 equals the log of 30. And to isolate the x, if I divide by the log of 3, then I get x equals log of 3 over the log of 30, which gets us into a place where we can put that in the calculator because there's not a great way other than this to solve it. So log of 30. And just to make a note here, if you use the division symbol, you have to close the parentheses. So log of 30 divided by log of 3, we get 3.0959, so 3.096. So x is about equal to 0.096. So if I raise 3 to the 3.0959, so on, power, that's going to get me to 30. Okay, we'll look at a couple more. All that's really being added here is a couple of algebraic sequences. So for number 2, for instance, I would just add 4 to both sides to get 38. And so 10 to the x power equals 38, which means I'll do log of both. And what I've got to have is the exponent here and then just one portion of something over here in order for me to put it inside the logarithmic function. And the pattern is going to follow the same. To find that x, we're going to do log 38 over log 10 and work it through that. So again, just dividing. That x is going to move up front. And you'll start shortening these steps pretty quickly as you've got the pattern down. But just doing log 38 divided by log 10. And I get 1.5797, so 1.580. So x is about equal to 1.580. Okay, we'll go through a couple more, but the process you've got is the same. So again, just a few steps on the arithmetic sequences. So 21 minus 14 gives me 7. So 5 to the x power equals 7. And you already probably can see, well, I'm going to do log of 7 divided by log of 5. And so as you're working on shortening it, you just know you're going to divide going across there. So log 7 divided by log 5, 1.209. Okay, and not going to really run into anything major here, just more algebraic steps. Again, I'm working to get everything all the way on its own. So subtracting 4 from both sides, 15 equals 3 to the 1/2 to the x power. Now remember, I can't leave this 3 with it. I'm going to need to divide this by 3 in order to get 1/2 x equals 5. And so that would be log 5 and log 1/2 to the x power. So x is going to equal log 5 divided by the log of 1/2. And we'll put it in just like that. Log 5 divided by log 1/2. You could put it as 0.5. Works perfectly fine. But you can also put a fraction in there and you're good to go. And so you notice we can get a negative number. A negative number just means that if I raise that 1/2 to the negative 2.32 power, it's going to turn it into a whole number and get it up to 5. So x is about equal to negative 2.322. Okay, now you've got maybe a little different here, but the only real difference that you have here is that we're going to do the log function and then have some algebraic sequence to do. So mainly I'll do the log of 3.6 over log of 2, and then you're going to get that equal to 4x. And so my last step would just be to divide by 4. So it's log 2, but I'm moving the 4x up. So 4x times the log of 2 equals the log 3.6 divided by the log of 2. And we end up with 4x equaling the log of 3.6 divided by the log of 2. And that equals 0.847996907. Copying the whole thing out, but really all I'm going to do is when I'm dividing by 4, I'm just going to do answer divided by 4. So that way I'm getting it as accurate as possible. So just dividing what I got by 4. So x is going to be about equal to 0.462. And the last one, doing similar process. So doing the log of both should give me x plus 4 equaling the log of 3 divided by log of 19. So really the main thing here for you is to make sure that on the right side that logarithm is on top, other one is on bottom. So I get log 3 divided by log 19. So x plus 4 equals 0.373143. And I need to subtract 4 from that, but I'm just going to do answer minus 4. So minus 4. And we get our answer. So x is about equal to negative 3.627. Okay, so just some basic algebraic processes there to go through along with our logarithmic functions. Just make sure we don't get kind of mixed up or tripped up as we go along.